We're back. It's working now. Good to see everyone. Who is there? A lot of things fixing up. Hair's shorter. Shorter hair, Brian. Here we go. So with this, we're going to do a little 320 here today. Let's wake up Mewbot. Mewbot breaking the universe. There we go. Short hair. Still not used to it. Get used to it after a little bit. So let's do a little 320. Here we go. Over to 320. Okay, BAS 320. So let's go here at the 212 mark. BAS 320, assignment 6, checking regression. So how do we do checking regression? How do we possibly do that? Well, we need to make a regression. Now, I'm not using what you're using. I think we list out the steps here. You need to load in data to start. You're going to need to go over to Kaggle. And on Kaggle, you will find a CSV file. On the file, you will do something like my data. It can be called whatever, read.csv, and you'll do whatever the name of your data is. And usually we do strings equals true. Won't matter so much because we're not dealing with categorical data. So that's not going to be the most important things right here, but you'll have to load in your data right there. You will need to make it look as follows. I would preferably not call it my data. If you're working with like NFL data, we call it like NFL. If you're working with movie data, movie, you can call it different things. That's just the name you allocate it to that goes into the global environment. You'll read in a CSV file because you're going to find a CSV file, comma separated values on Kaggle. And then you will do the name of the file right there. And then strings equals true. Probably, once again, it really doesn't matter. Rock knows because you're dealing with quantitative data. So let me go over here and pull up the assignment. And huge shout outs to Linda, who always posts such amazing walkthroughs for us. So Linda really details everything on how she'll be grading these, which is really awesome because then you can see the full breakdown on how Linda will grade these. And I really got to say, Linda is just all-star TA right there. So we're going to go over to the assignment here. I'm pulling it up as we speak. And we've got assignment 6, checking polynomials. And Linda has, I think she sent it out, assignment outline. Here it is. So here we go. Here's the full thing. And Linda has sent out the assignment outline here. We're opening it up. And there's the full outline right here of the assignment. Bryant, good to see you. Thank you so much right there. Appreciate it, Brian. Got the hair cut off. It's nice and short now. So then we'll just let it grow back out again. So short hair, Brian, for a little bit. So if you notice right here, choose a Kaggle data set with at least 2 quantitative variables. And then you're going to give a brief description, which is like mean, standard deviation, all those things right there. Explain the practical relevance to what we're doing right here with this analysis. You got it. And then 2 visualizations, histograms, flex tables, all that stuff. So if you're working here with something like, you wouldn't work with this, but the empty cars data frame, you can make a histogram of empty cars. But the thing is you don't want to just turn in graphics that look like this. Think about how easy it is to make a better looking graphic. So we are going to pull up ChatGPT here, and let's say making better graphics. We're going to put this part of the video right here. Because BAS 320, assignment 6, making better graphics. So we'll put getting started. Okay, so we got ChatGPT over here. And I will say, I am doing a project in R. So we need to tell it the language we're working with. I want to make an amazing histogram using ggplot2. Also, give me a table using flex table that summarizes this variable with the 5-number summary and the mean. Now we're going to give it this. Okay. So notice how this prompt works. How to give a good prompt is to be very specific. We told it the coding language right here, so it learned the coding language we're doing. We also told it we want an amazing histogram. We even told it the library to use, which is ggplot2, which is the grammar of graphics. Then we have used flex tables, which is going to put our summary into a really nice table. Like think of an Excel table, like it's going to look nice. And then we told it we want the 5-number summary, which is min, Q1, median, Q3, and max. And then the median 5-number summary is the percentiles and the data. How you doing, Bryant? Take a look at this. Look at all this code we get for free. All this beautiful code. And I should have all the libraries loaded up. I'm going to zoom out here a little bit. We drop in the code. We just got about 40 lines of code for free. We load up ggplot2, we load up dplyr, we load up flex table. Now, if these are not loaded up, you need to go down here to the bottom and do install.packages with things like dplyr, but it's already loaded up, so we're good to go. We get our ggplot here. That looks all right. All right. Yeah, I don't know. You can change around with the colors here. If we go here, FF8200, we get UT orange. It's all what you want. Theme minimum. You can go theme, and you go to a ggplot theme, like theme dark. That looks like UT colors right there. I like that. So you can just try different themes, and there's library GG themes. Do I have it? I do. So now if I go over here to the themes again, after I load up GG themes, you can see GG themes right here, like the calc theme right there, and you can just easily change the theme of it. And you don't want to use a flex table theme though. You just want to try other themes to see what is good or bad. And then you can do additional changes in ChatGPT changes. So it's very important you know that the themes just change everything, but you have to use a theme that is either GG themes, if you load the GG themes package, or a ggplot2 theme. Like maybe you want to do it like that. It's all whatever you want. And of course, talking to ChatGPT can get you a lot of really great things. 538, I actually don't like those as much. 538, really big back in the day. Still big, but solarized. I don't know. You can do that right there. You can change the background color, all these different things. Can you do BG color? Might actually be that. Let's try this. BG. No, BG equal. Didn't work. I don't know what the background. Let's say this. Fix this so the background is pink. Fix this so the background color is pink. Going to try to figure out what I want to do. Element, there we go. Plot background. So it's doing it right here. And there it is. There's the theme. So we'd actually grab this right here. And then we would take this and drop that on. And there we go. I mean, and then that's plot background, I think. Plot background, go white. Actually, that looks pretty all right. I'm kind of all right with that. All right. And there's just a lot you can do. Yeah, like font sizes and stuff. It's about making it look nice, whatever you want. You pick, you do. You make the graphic look good. You redo titles. Make the graphic look nice. That's how we do. Next, we go down here. You can get a summary, and we're going to print this summary right here, and here it is. That's a pretty good summary. The decimals, I would say round everything to 2 decimals. So grab this. You think about how this could look better. So you go back here. You say, I need everything rounded to 2 decimals. Also, I need the column header in a light gray gravy color. So once again, we're just trying to make really good output right here. We're taking a look at it. We can do a lot of these things ourselves. You can see where it's summarizing, getting the minimum value, the Q1, the median, the Q3, the max, all those values right there. Redoing it as a summary table, setting the labels right there. Doing the theme vanilla, so we can change that theme if we want. We're going to grab this code and overwrite what we have right there and redo the summarization of it. And it didn't change it. And now let's reprint it. It's changing the color of that. We don't want that. And this is a flex table. So you go here and you change the flex table theme to different things. Let me go here. Let's try this. And say, I don't want the font to be gray. I want the background color of the column headers to be gray. Please fix this. Also, and other cool things. I don't know. Sometimes I leave open-ended questions for it. I know I say be very exact, but it looks to be getting now header background gray. It's redoing it right here. It's constantly redoing. I'm going to run out of ChatGPT today because I'm asking it to do like one task a billion times. Setting the theme, there we go, there's the BG. That's what I've seen. I've seen BG before, background color. And it's bolding the header. It's removing the border. It's doing a bunch of other cool things. Let's see how this looks. Okay, we're going to go in, repaste the code. And let's take a look right here. Uh-oh. What did it do? Oh, because I didn't take the full thing. I'll paste it in the middle of code. There we go. Okay, now, what? Something's broke. That's broken right there. Okay, let's find out. I think. Let's paste again. Ooh, something's not good. Let's retry. Oh, it's just redoing this. No, okay, copy. Was working. This is broken. Unexpected comma. It's right here. That closed it off right there. Okay, so something's going on right here. It's closing the quantile. That's closing the summarize. Oh, so why is there an extra 2 right there? Okay. Make it manually write code. Warning. Max round to round this to this. Okay, wait. Let me do this. There we go. Q3 and quantile. Doing it myself. There we go. FP border, we actually found this out during office hours. We need to go here to library office R. Yeah, that's good. That's about best we're gonna do. And all that work for that little table, but looks pretty good. And we could try different themes on it too. So we could go to the different themes of flex table and see what we get and just try different things and then find one we like and use it later. Oof. Eh, not bad. But yeah, just try things you want to see what they look like and see if they're any good. And you get your different flex tables. But just changing the theme is usually one of the quickest ways to change things up. But yeah, just make them look nice. Test. I can't use that one because that's a ggplot. So there we go. You'll look at ThemeTron right there. So we've got a summary table. And the summary table is showing us the values of it. So we can see the values of the quantitative variable. Let's go back and look at the assignment again now and see what we need to be doing. Model analysis. So if you take a look at this right here, we are going to fit a model, show the regression equation, talk about the coefficients, and visualize it. So how do we do those things? Let's go down here and put a note in here. So at this moment, we are at 1423 and making a simple linear regression. Okay, so to make a simple linear regression, we simply do M left arrow, make it bigger so you can see. We do M left arrow, LM, and then we do something like weight tilde miles per gallon, data equals, I don't want it to be off the screen, MT cars. So the format of this is y tilde x comma data equals. Y tilde x comma data equals. That's y tilde x comma data equals. Y tilde x comma data equals. And so with this, we can now plot the model and visualize it just like this with reg class. So we go to reg class and we go to visualize model. Reg class is decent at visualizing models. It's not so pretty, but you can easily take this code right here over to ChatGPT and say to ChatGPT, make the most beautiful ggplot2. I can't even spell beautiful today. Beautiful ggplot2 for me of this regression. I need 105 in the class. Now, it probably will put in titles like most beautiful ggplot2. So watch out. It usually does that. It says like most beautiful ggplot2. We'll see that down here in the title. It didn't do it. Subtitle linear regression with 95. Ooh, did 95% confidence rolls. Caption, it put in, we could change the captions and stuff. Ooh, we put the R squared in there. I like that. That's a very good model. We might be running out of our ChatGPT soon, though, so we got to watch out. So with this, very quickly, we can take this so-so model, and wow, there we go. Look at this. Much better. Really good. That is, you think about how much extra we got right here. It's got 95% confidence intervals for the true mean of the line. We could change the colors to whatever we want. We could make this UT themed. We got weight in 1,000 pounds. Got some context there. Relationship between miles per gallon and weight. Linear regression with 95% confidence intervals. The R squared is put onto it. We've got the data, empty cars. So what we could actually do is we go here to summary. And here are the coefficients. They're right there. And let's go to the equation. And we could say the following. We could say predicted weight equals, and then 6.047 plus or minus, excuse me, because that's a negative slope, and MPG. And now we rerun it, and there it is right there. So if you take a look, we now have the regression equation at the bottom of the screen, and we could change font sizes and all these things. It's a little busy, but it actually contains pretty much everything we would ever want. We can work with the colors, the size of the points. You can see right here, if we want to go with UT orange again, we could do the UT orange theme right there. I did one too many zeros. FF8200. I did an extra 2 by accident, very close to the right UT orange. There's UT orange. And we change the color of the line or something to smoky gray, which I think is 585859. Close enough. There we go right there. We can change the R squared color to F85859. Sure, close enough. And just whatever you want. It literally is all preference. And you might say that extra caption right there is too much with the 95% confidence intervals. So we're going to go to the subtitle, delete it, and rerun it. And there we go. And one trick I have that I really like, that's a pretty darn good graphic right there. It's got the model below it. It's got the Y, it's got the X, and it's got the R squared on the plot. So you can actually tell the intercept, the slope, the predicted variable, the X variable of interest, or X variable of interest. Usually I switch these and usually have Y and X for predicting miles per gallon instead of weight, but today we did the reverse. But this right here is a really good visualization. It has a lot of information. It might be a little bit too information dense. So you could, of course, some people might argue, don't have the caption. And it's kind of nice because you can just literally go and just delete things if you want and remake your graphic. And then you have this right here. So now only the extra thing we have on here is the R squared. It's all preference. It's all what you want. There is no one perfect way of doing these things. There's good, better, and best. And I'd say this is pretty darn good. So now that we have this graphic right here, we need to go and check the regression. So let's talk about how to check regressions. So how do you check regression? Checking regression. How do you check a regression? Well, you simply run check regression on it. And what does this all mean right here? Well, when we check regression, we're seeing if there's issues. Low p-values indicate problems. No problem with linearity. P-values above 0.05, just barely. Since we're doing simple, the p-value of the x is the p-value of the model, so they are both good. Equal spread is also good because the p-value is above 0.05. Normality is bad, and it actually doesn't look bad. That is shocking. The normality does fail, but the test over here follows the QQ plot for normality, or follows the line. I am shocked that it actually failed. Now we found a better package for making these plots. It is library ggfortify. Library ggfortify allows you to use the autoplot. You have to have ggfortify on to use the autoplot this way, and you simply put in your model and you say which. I guess that is a comma, even though I can barely see it. And you do 1 through 2 are the only ones we're going to look at. These are the plots you're going to look at. You can see a little bit of the non-linearity, and these do have row names, so we can see which cars are the big outliers, the Fiat 128, the Lincoln Continental, and the Chrysler Imperial, sure. And so those are kind of breaking away, and I guess I do... Oh, it's got a bend in it. I guess that's why it's failing normality? Sure, that's why it's failing. And overall, this isn't a bad model. Overall, this isn't bad. We can try and make a worse one here. I'll make a classic worse model that I show because I want to show a bad check regression. So here is I need to pull up the data first. Data survey 10. This one will fail more conditions. M save into LM. We're going to predict the height of a person by the weight of a person with data equals survey 10. And now we run the check regression, and here's what we see. We fail linearity. We fail equal spread because these p-values are low. We fail normality of residuals because the p-values are low. Now when we run the GG Fortify, we can get a better look at these two plots, and we'll keep this over here. You can see the nonlinearity because of the way it bends throughout. This is the true form of the model. The blue line, or the blue bendy line, is the true form, telling us that the linearity doesn't follow the line right here. This is a perfect linear model, and we are not following it. If I show you the visualized model of this, which we might even be able to make right here, no, we'd have to switch the variables. It's actually not that hard to change it. The one problem we're going to have is all of our headers are not going to be the same, but we can easily change this model right here using this code that's pre-written for us and put in our variables and get a height weight. There's some adjustments we would need to make, but you can see the bend at the end of the model here. And fun fact, you can also make the model bend if you change this to the LOS method, which is the local estimate method. And then we could work on changing this. But notice how it would bend. It has that dip. And that's what we were seeing over here, where it has this like dip right there. That would be the true form of the model. So overall, the linearity for this model that we're looking at right here looks to be a problem. We should probably be fitting something that is allowed to bend through it. And we see the normality of residuals has a problem, and the equal spread has a problem too. The equal spread showing up with a very low p-value is probably because the model gets a little thinner as it goes throughout. The plot is thinning, and we want about equal spread throughout. And once again, you could see this in the other plots. If we look at the plot right here, you notice it's thicker in here and gets a little thinner as you go through. So we don't want the plot to get thicker or thinner in any way. So when you do a check regression, you do want high p-values. So the very first one we ran way back when was a very good check regression. Hence why I was like, well, darn, I need to find one that's not doing so well. So I went and ran a check regression that actually failed some of the issues. So here's the one that passed, and actually it failed normality. But we looked and it wasn't that bad. Then we went down and did this and it failed all of them. And then we look at the conditions and we say, uh-oh, linearity is not good. Uh-oh, it's not about the same equal spread. Uh-oh, it has big outliers on the normality of residuals. So that is how we check regression. You first look at the p-values to see if they're low, to indicate if there's problems. And then if there are problems, you go and you look at the diagnostic plots. And autoplot right here has the best versions of them. Let's talk about transforming and choose order to end off right here. Got a late start today. It's been a busy day. So here we are. And I do want to say this. Let's do this first. Making your summary look nice. Okay, so when you have a summary of a model right here, you really want the summary to look nice. So let's say the following. I need the most beautiful summary in a flex table. The column header needs to be a nice color. And also make sure across the bottom row, add in R squared adjusted, and RSC. Yeah. If you haven't had those in, that's fine, but we can just present them all. That way you don't have to call them back. You can just be like, they're included. And it should be able to extract all them. It should know where to find all them. It should know the names of them. It's using model metrics. There it goes, making the model metrics thing. It's binding them together. It's taking the summary statistics and the model metrics and row binding them, or row binding them, because this is column binding. This is row binding because rows go this way, columns go this way. So we're going to copy this code. It's still going. Just a lot of code. And let's see. There we go. We're on like 110 or so. And here we go. There is our model from previous. That's, man, that's got it. There's the model metrics, everything. That's all the model metrics right there. That's the, and I really like what it did right there. Put the model metrics as like its own like little bloop thing. That's a really good table. Probably I'd like it if it had the lines between. I prefer that. So theme vanilla, we're going to go from theme vanilla, and we're going to try theme alfalfa. No. Let me see. Is it removing bold, color, auto fit, padding 10, border remove? There it is. I didn't do it. Border outer, part all, black. Ah! I don't like that. That's fine. Really one of my things. Where's... I could ask it to do it, but I'm trying to find it. That looks pretty good. I don't know where it's removing it. What you can do is you can go right here and run it there and then see what it looks like. Yeah, look at all those extra things we got. So we definitely want to keep improving it because I'm losing my mind. There we go. Yes, looks way better. Okay. Looks pretty darn good. Everything is rounded, I think, to 2 decimals, or like we just want to make sure the rounding is good on this. Let's look at the way it rounded it. 3 decimals. I'll take 3 decimal rounding. We'll actually, let's go to 4 decimal rounding. We'll increase the decimal rounding on these. So we want 3 decimal rounding on that, 3 decimal rounding on that. The p-value will round to 6 digits. And then the r squared, those are good to 3. Yeah, okay, we increased the decimal rounding. And there we go. Looking good. Looks like an excellent table, excellent values. Very, very proud of this work right here. And if we want to go FP background, ooh, there it is. We did it. Oh, that's better. I like that. And I want the text to be black. Color white. 000000. No, it's hashtag. Oh my gosh. 0000. No. FF. Ooh. These are hexadecimal color codes. Oh, I got an extra quote. Ah! Don't want to do that. That's that. Oh, so we could just take this. Okay, look good. And then changing. Oh, that's getting mad about this. Let's go key value. Really? There it is. Oof. What have I done to it? What have I done? Is it like a pending on every time I do it? What have I done? Oh, out of bounds. Oh, because it's looking those up. Oh. It's this. This is where I need to change it. Good. That's got it. Oh, and I broke it. I am breaking so many things. Okay. This is why we have rewind history. Wait a minute. Where'd my p-value go? I gotta write that now? Where'd my p-value go? Paste. Oof. I'm gonna grab that code. Here we go. I don't want to rewrite that. That should be good. Good. Equals. No one equals. And I want to rewrite this to p value. Oh my gosh. What is going on? No, it's up here. I have broke this. I have severely broken this. If it's not broke, don't fix it, right? If it's not broke, don't fix it. So it'll do a little choose order to end off. What do they say? Perfect is the enemy of good. Never do that. Okay, a little bit to end off right here. Let's talk about the choose order because we got to run here in a moment, so we got to finish up. I could just work on these things all day. I know you think I'm crazy, but it's like, I love it. Choose order and find transformations. Okay. So with choose order and find transformations right here, we can easily do choose order of our model to see if there's a linearity issue. And this is the model over here. And we can do find transformations to see if transforming our model would help it out. And there are transformations that could possibly help. Log 10 of the y and 0.5 or square rooting the x. So with the choose order over here, we notice that it probably would be best if we brought it to a second degree polynomial, which is just if we go here and look at max order, let's find transformation. Max order equals 2. And that's probably going to be a better fit. So let's go ahead and take our code again. And we're going to go here to the linear model on cars. Going back to ChatGPT and say, fit a polynomial to second degree to this model and ggplot to it in an amazing way. And make a summary table of it, of the coefficients you did previously. Okay. So here we go. We're getting the second degree polynomial with fit. It's probably going to use there it is the poly command. This gets you the exact coefficients with raw equals true. And then we're saving the model summary right there. It's doing the same things we did previously, getting those extra values. Now it's probably going to, after this, start doing the ggplot2 of it. So we're getting the same exact tables we previously got, all the same themes. And then going down further, we should start seeing our ggplot2 of it eventually. Here's the plot of it, the ggplot2 of it. And there it is, it's fitting a linear model, but it is a polynomial. So we'll see how this looks here in a second. And then we would want to do a check regression on this to see if it improved anything in the regression. So we're going to copy the code, a lot of code right there for just a little bit of what we want. And here it is. My gosh, I should have looked at which line we were on. I think we were right about here-ish. That's where we were at previously. These are all the summary statistics we did. Now here we go, choose order, find transformations. Now we are back. There's the polynomial model. There's the summary of the fit. Here are the coefficients bound together in a new summary table. And we should be seeing that. I guess it didn't plot it. So here's kind of crazy thing. It made it, and then it didn't show it. There you go. There's the new polynomial term, which is statistically significant in the model. And now we can see the visualization of it. There we go. We've increased the R squared. And these are the things you kind of want to be looking at here is, does your R squared go up? And then also, if you do a check regression on this, if we go here to check regression of the polynomial model, you want to ask yourself, did we get a better model? And we can look at these things by wondering, did we do better on the conditions? And the answer is, we pass this, we fail this, we pass this, we pass this, we pass this. We can also, once again, do the auto plot here to get an idea of what's going on. Not auto loader, but auto plot. And we can put in the mpoly into this. And with the polynomial model here, we can do which equals 2 for which ones we want to see, 1 through 2. And we can view the plots. We still have a little bit of an issue here. We do have 3 cars, different ones this time, that are kind of going away from the model. Once again, there's only a problem with linearity, and it really hits the polynomial trend. Now, you might be wondering, what's the point of all this? The point of all this is to see how good your models are, to make comparisons. If you make a linear model, does it do good? How good does it do? What's the typical miss? Well, the typical miss of the model is going to be the RMSE. My typical miss is 0.433, and then previously my typical miss was, this is the 1 RMSE, 0.479. So the new model has a better typical miss in it. So with this, your goal is to find out, can you make good models that predict the data well? And that's kind of what we're doing in the class. So if you have questions, let me know. But I want to make a short video right here today especially. I'll save it in here. But how to do a lot of this assignment, I didn't quite do it all. I didn't write it all down. But if you notice what Linda's done is she's listed everything out right here where you go through, visualize, compare, check your assumptions. So she's really got a good step-by-step written down for you, which I was basically going through right here, doing model comparisons and what we have. So with that, we'll be back tomorrow. Bye for now, everyone. Bye.